Welcome guys to the new video series in Introduction to Cloud Security. As more and more organizations are moving into the cloud security becomes an essential skill to leverage. So I wanted to, in this series, to discuss some of the concepts around what is cloud, how do we leverage cloud security, cover some of the shared responsibility models, cover some of the cloud deployment models, cover some of the most common misconfigurations and some of the concepts that you need to know if you are deciding to leverage the skills in the cloud security and you potentially looking to move into cloud security as a career path. So I wanted to start with some introductory concepts around cloud security and then take this series further and as we dig deeper into the cloud security concepts and how we can leverage those skills to upskill ourselves in cloud security. So firstly, we have to answer the question, what is cloud? As published by National Institute of Standards and Technology, cloud computing is a model for enabling ubiquitous, convenient, and on-demand network access to a shared pool of configurable computing resources, such as networks, servers, storage, applications, and services that can be rapidly provisioned and released within minimal management effort or service provider interaction. This cloud model is comprised of 5 essential characteristics, 3 service models, and 4 deployment models. So, essential characteristics of a cloud is on-demand self-service. So a consumer can unilaterally provision computing capabilities such as server time and network storage as needed automatically without requiring human interaction with each service provider. So it's a broad network access. Essentially, that's what the capability is. So these capabilities are available over the network and accessed through a standard mechanisms that promote use by heterogeneous, thin or thick client platforms such as mobile phones, tablets, laptops, and workstations. It also covers resource pooling. So the provider's computing resources are pooled to serve multiple consumers using multi-tenant model with different physical and virtual resources dynamically assigned and reassigned according to consumer demand. There is a sense of location independence in that the customer generally has no control or knowledge over the exact location of the provided resources, but may be able to specify a location at a higher level of abstraction, such as country, state, or data center. So if you have any interaction with the cloud, you may be aware of that normally when you provision resources in the cloud, you can choose a region, sometimes even use availability zones. So normally cloud providers have regions split across the globe. And normally each of the regions are further split into availability zones that are essentially each individual data center. So if you compare, for example, something like Microsoft Azure and pick, pick one region. If we pick a region of UK South. So UK South is a region, one of the regions in Azure cloud, and that region has 3 availability zones. So if you review the documentation in Azure, it says that each availability zone is one different cloud data center that has to be split by at least 60 miles to provide resilience. So essentially what they cover with that is that if there is a specific power outage or anything something similar that can cause a disaster, each availability zone has a separation of at least 60 miles to make sure that they use different power provider, different internet service providers, so to make sure that they can provide resilience to their clients. So examples of these resources include storage, processing, memory, and network bandwidth. The next characteristic is rapid elasticity. So capabilities can be elastically provisioned and released, in some cases automatically, to scale rapidly outward and inward to commensurate with demand. So what does that mean? Scaling outward and inward. So when we deploy cloud resources, there is a horizontal scaling and vertical scaling. So what do we mean by that? So essentially what it is, if we scale our resources vertically, what do we mean by that? Essentially what we mean by that, so if we provision, say, a virtual machine with 2 vCPUs and say 4 gigabytes of RAM, when we scale vertically, what we do is we upgrade that specific virtual machine to include more vCPUs and more RAM, so essentially it becomes more powerful. Whereas if we scale it horizontally, what we mean by that is essentially we adding another virtual machine. So that's what we means by elasticity in the cloud. And last characteristic is measured service. So cloud systems automatically control and optimize resource use by leveraging a metering capability. So at some level of abstraction appropriate to the type of service. So storage, processing bandwidth, and active user accounts. So resource usage can be monitored, can be controlled and reported, providing transparency for both of the provider and consumer of the utilized service. So what do they mean by that? Essentially is when we deploy our virtual machines, normally the costs are provisioned per second of use. So anytime the virtual machine is running, the costs are metered every second that virtual machine is running. As soon as we stop the machine, the costs are no longer included in the use of that virtual machine. So one of the first important lessons when we move into the cloud is understanding the shared responsibility model. So as you can see, the main kind of 3 responsibility models within the cloud are infrastructure as a service, platform as a service, and software as a service. So software as a service essentially is the capability provided to the consumer to use the provider's applications running on cloud infrastructure. The applications are accessible from various client devices through either a thin client interface, such as web browser, or a program interface. So the consumer does not manage or control the underlying infrastructure, including network, servers, operating systems, storage, or even the individual application capabilities, with some of the exception of limited user-specific application configuration settings. So what do they mean by that? So essentially, software as a service is something like potentially some examples like a Gmail email service. So essentially, when you log in, you only are responsible for the data that is held on your Gmail account. You don't have any responsibility on the applications, on the operating system, on the virtual networks, even hypervisors, or any underlying infrastructure that sits under the Gmail. So essentially, the choice is that if you can, you move as high up as possible towards the software as a service, because you offload the responsibility to the cloud service provider. So CSP in this graph is cloud service provider. So that's where their responsibility lies. Now, if we move it into platform as a service, so the capability provided to the consumer is to deploy onto the cloud infrastructure consumer created or acquired applications created using programming languages, libraries, services, and tools supported by the provider. So the consumer does not manage or control the underlying cloud infrastructure, including network, servers, operating system, or storage, but has control over the deployed applications and possibly configuration settings for the application hosting environment. So normally, platform as a service are usually things like Kubernetes services, managed databases. So for example, Everybody's probably heard about SQL database. So there is a few ways in cloud that you can deploy SQL databases. If you need to control the actual underlying virtual machine, you would normally deploy it on infrastructure as a service. But if you don't need access to operating system or virtual networks, you would normally deploy SQL managed database, which is a platform as a service that's provided in most of the cloud service providers, or something as Kubernetes services are, again, it's a platform as a service. And lastly, infrastructure as a service. So the capability provided to the consumer is to provision processing, storage networks, and other fundamental computer resources where the consumer is able to deploy and run arbitrary software, which can include operating systems and applications. The consumer does not manage or control the underlying cloud infrastructure, but has control over operating systems, storage, deployed applications, and possibly limited control of select networking components, such as host firewalls. So that's essentially the shared responsibility model. I think it's very important lesson to address and to take care of, because I have been talking and presenting over various events about cloud, and there are some people who still do not inherently understand shared responsibility model. And that's why we often see that most of the breaches in the cloud happen due to misconfigurations or sometimes essentially lack of knowledge. Like, most of us hear about stories where machines are left wide open to the whole internet, and obviously breaches happen, vulnerabilities are not addressed, and things like that. So understanding where does your responsibilities lie and where does cloud service provider responsibilities lie is very important, as this is the only way you can achieve security, knowing where to who is responsible for what and what you need to do to secure your services in the cloud. Sometimes people, I think, it's tricky sometimes to understand the shared responsibility model. So I often like to use example of pizza as a service analogy. So this is a great graph and great example, and we added a few extra components in the graph just to make it more understandable and more up to date, because as we discussed in the previous image, we had infrastructure as a service, we had platform as a service, and we had software as a service. But we have new deployments within the cloud, such as containers as a service increasing, as well as function as a service, and some of the cloud deployment models are moving to serverless deployment. So we address these in the further series, but just to break it down for you guys. So as you can see, all the way on the left, we have traditional on-premises sort of legacy architecture deployment. So if we look from sort of pizza as a service view, essentially, if you make a whole pizza, you make the dough, everything you make at home from scratch, that's your traditional on-premises legacy architecture, a homemade pizza. Now, if we move into infrastructure as a service, essentially what we do is we make a pizza in a communal kitchen. What do we mean by that? So there is an oven. For example, you live in a shared accommodation with another 5-6 people, and obviously there is a communal kitchen that everyone gets to share the oven as well as electric or gas, depending on how that oven is powered. But when you do infrastructure as a service, you need to obviously turn on the oven or electric oven or gas oven. So obviously you need to provide the fire, you need to bring the pizza, you need to bring the beer, the friends, and the conversation. So that essentially is the infrastructure as a service. Now, if we move up to containers as a service, obviously cloud service provider in that case, or pizza service provider, takes care of fire as well as oven and electric, same as infrastructure. So now we don't need to anymore to turn on the fire. So essentially it's bring your own pizza. So we just bring pizza, we bring beer, friends, and conversation, and that's how containers as a service runs. Now if we move up the pyramid and go to platform as a service, essentially this is the same example as we would do with the takeaway pizza. So if we, for example, order or pick up a pizza from someone like Domino's Pizza, yeah, so they take care of the electric and gas, they take care of the oven, they take care of the fire, as well as making the pizza. So all we have to do is just bring beer, friends, and conversation. Now, as I mentioned before, we have new types of deployments moving, such as function as a service. So function as a service is essentially it's a cloud provided environment where we can run specific functions where development can put their code and run specific functions. So this is essentially the same as eating pizza in a restaurant. So what do we do? So obviously all we need to do in the restaurant is bring our friends and bring conversation. The beer, the pizza, the fire and oven, as well as electric, is taking care of the restaurant. And now the last piece, where is software as a service. So it's the same example as we would be going somewhere to a party. So the friends are already at the party, the beer is there, the pizza is there, fire is there, oven and as well as electric and gas is there. So all we need to do is bring ourselves in a conversation, and that's an analogy of software as a service. So hopefully that, guys, gets you a bit more understanding of how do we share the responsibility model in the cloud. Now, as I mentioned, guys, there's a few key concepts. Whether you are an organization that's decided to shift their operations into the cloud, or you're deploying any particular new resources, there is an important decision to be made, whether we choose infrastructure as a service, platform as a service, or software as a service. So essentially what it is we have to think and define how much control do we need. If we need to control the underlying virtual machine, its operating system, then obviously we move into infrastructure as a service. And as I mentioned before, guys, same as with platform as a service, we have in cloud deployments, we have managed databases. So if our infrastructure, if our solution does not require access to underlying virtual machine where, for example, a SQL box sits, then we move into less control but more security coverage and more responsibility towards the cloud service provider. Then we use something as like platform as a service. And then after we move up the pyramid, we obviously lose even more control to software as a service, but we outsource the responsibility of security to cloud service provider. So software as a service, the only thing we need to be aware of and take care of anything is secure our data. So make sure that the data is encrypted and making sure that access provision to that data is only to those people who have relevant business use case to have access to that data. So essentially it's always a decision when you're deploying specific cloud architectures or you're building specific solutions. You develop business cases to determine how much of a control you require. Sometimes obviously the decision is out of your hands, because if you need to integrate specific solutions, sometimes you will need infrastructure as a service, sometimes you'll be able to leverage platform as a service. But nowadays, obviously, because cloud service is becoming onerous to manage, and obviously organizations don't have enough staff to manage so much, organizations are moving as much as possible up the pyramid to outsource the security resources and security decision making to cloud service providers. So you leverage software as a service as much as possible. But as I said, essentially it's up to the architecture and up to the decision of how much control you will need for that particular service to make a decision of whether you use infrastructure, platform, or software as a service. Now, as I mentioned in the beginning, we covered shared responsibility model. Now let's cover cloud deployment models. So as you can see, there is 4 types of cloud deployment models: public cloud, private cloud, hybrid cloud, and community cloud. So let's just jump straight into. So what is private cloud? So private cloud is a cloud infrastructure provisioned for exclusive use by a single organization comprising of multiple consumers, such as business units. It may be owned, managed, and operated by organization, a third party, or some combination of them, and it may exist on or off premises. So essentially, private cloud is a dedicated cloud infrastructure to one specific company. So typically have a massive amount of available space, which translates into easy scalability, recommended for software development and collaborative projects. So this was the definition of the public cloud. So public cloud infrastructure is provisioned for open use by the general public. It may be owned, managed, and operated by a business, academic, or government organization, or some combination of them. It exists on the premises of the cloud provider. So essentially, as I said, typically have a massive amount of available space, and it translates into easy scalability. So that's essentially is a public cloud. So let's cover next the community cloud. So the cloud infrastructure is provisioned for exclusive use by a specific community of consumers from organizations that have shared concerns, mission, security requirements, policy, and compliance considerations. It may be owned, managed, and operated by one or more of the organizations in the community, a third party, or some combination of them. Normally, what I say to people, community cloud is essentially a subsection of a public cloud, but essentially community cloud is a multi-tenant platform used by several distinct organizations to share the same applications. Users are typically operated within the same industry or field. So it's essentially community cloud. What it is, it can be made up of number of organizations that create a community, or another version I think of community cloud can be considered is Azure, same as AWS and GCP. They have a government cloud that are separated from the public cloud. So government clouds where government organizations deploy their infrastructure could be used as a community cloud. And then lastly, hybrid cloud. So the cloud infrastructure is a composition of two or more distinct cloud infrastructures, private, community, or public, that remain unique entities but are bound together by standard or proprietary technology that enables data and application portability. So essentially, hybrid cloud is a combination of public clouds with private clouds to allow two platforms to interact seamlessly. So some organizations decided some time ago potentially that they build their own private clouds. But as the times moves on and the accessibility and usability of the public cloud became so easy, the organizations might leverage something like a hybrid cloud. So they would have a private cloud that connects directly to their public cloud, and that's how we have a deployment model of hybrid cloud. Now let's address some of the important concepts within security in cloud computing. So in cloud, users have a significant security concern, and data should be permanently stored in an encryption format. It helps to restrict the client from accessing the shared data directly or with proxy to help with the brokerage services. So as we can see, the first step is security planning. So before deploying a particular service on the cloud, the user or the enterprise should analyze various resources as follows. So they have to choose the resource that is essential to move to the cloud and to examine its sensitivity risk. Users should consider a set of popular cloud services such as infrastructure as a service, platform as a service, or software as a service. In these three models of cloud, the user is entirely responsible for managing security at different levels, and as we discussed earlier. Users should choose the cloud type from public, private, community, or hybrid. The next step is to understand the system about cloud service providers, such as data storage, its transfer speed, and information about its cloud services. The risk in cloud deployment depends upon the cloud service models and their types. Second step is you also need to understand the security of the cloud. So a service model defines the boundary limit in the middle of the responsibility services of the provider and the customer. Also, you should check it out. Cloud Security Alliance has a stack model that defines the limitations between each set of service models and displays how functional units coordinate with each other. So here are some critical points of the CSA model, and they are as follows, such as infrastructure as a service is the most basic and the initial level, followed by the platform as a service and software as a service. In the next step, every step that comes with its service capabilities and their security issues. So infrastructure as a service will provide users with infrastructure. Infrastructure as a service has the most minor level of security, while obviously software as a service has the highest level of protection. The next step is to understanding data security in the cloud computing. So as an enterprise or a user transfers all of their data onto the cloud, security of data is a significant concern. So below is the list of some of the practices that we should think about within data protection. So you have to manage access control. You have to manage the audit performance. You have to make sure that all of the users are authenticated, and you only provide access to authorized users. Also, how we can isolate access to the data. So as data is stored in the cloud, multiple users can access it from any location. Therefore, a mechanism is essential to follow to isolate data and protect it from direct access. That's where identity access management has become very important. One of the few ways that we can address this is essentially a new type of service now called brokered cloud access control. So it's an approach for isolating data or storage in a cloud platform, and how it's done. So essentially a broker will have a complete access to the storage, but the client will have no access. So a proxy will be as long as the zero access to the storage, but can be accessed by both client and the broker. So a working process of brokered cloud storage access system. So the client, while requesting access to the data, will proceed to the external interface of the proxy service. The proxy then will forward the request to the broker, and then the broker will request the data from the cloud storage system. The cloud storage system will then reply to the data broker, and the data broker will return essentially the data to the proxy. So it's a way of creating zero trust access to the data in the cloud. That's one of the ways we can do it. Now the next step is to cover encryption. So encryption helps in protecting the data. It secures the data which is being transferred and also the information which is stored inside your cloud. And encryption helps in protecting the data from any unauthorized users, as it helps prevent data loss. Step number 5 addresses the areas to secure in cloud computing. So users can fulfill their requirements by adopting cloud technology. They can take advantage to plan and design cloud deployments. Also, they can arrange to plan the security configurations to be built in the initial phases to avoid threat and risks. So by protecting each section, IT teams can plan for future deployments quickly and confidently. So what are these deployments? So networks. One of the trickiest and challenging sections is network traffic inspection in the cloud. It can be a defense line protecting against zero-day attacks from known vulnerabilities. Protection can be provided with the help of virtual patching. So cloud provides a firewall to the users, and it is significantly different from the traditional firewall. The most critical challenge is the execution and deployment of the firewall, but the user has to take care of that configuration to make sure that it does not affect the network connections or existing connections in a private or cloud network. The next one that we have to protect is cloud instance. So security diagrams and structures change the complete understanding of securing the components. So in cloud, computing workload means a capacity unit or total amount of work done in the cloud instance. So cloud administrators face the challenge of protecting these workloads against security threats, malware, or any type of exploitation. So the reason cloud administrators are responsible is because they run the server, cloud, or container environments. So the user can deploy the instances as per request, but each instance should be monitored by a cloud administrator and governed especially by a security policy. Also, we should secure DevOps in container security. So in recent years, the software unit in cloud computing has become a trend. By using the containers facility, users can ensure the reliability of software compared to the actual computing area. The areas are complex to replace or maintain, and Kubernetes users are stress-free as cluster security assures them. For the development team and operations team, security integrity while developing the software is more beneficial. As the cloud app development is widespread, it means that the containers must be scanned for malware, vulnerabilities, and even during software dependencies. Also, it protects secrets and keys and also includes compliance violations. So users perform these checks as early as possible during the build because it's an ideal choice in continuous integration and continuous deployment pipeline for a better and smooth workload. And lastly, applications. So in some serverless or container platforms, traditional security cannot help in the deployment. So in many companies, fast and systemic programming and deployment of new applications are the main drivers for adopting the cloud. But note, these applications are solid doors for the runtime of web application threats like code injections, automated attacks followed by remote command executions. So to protect data, application security plays a key role. But unfortunately, if any attacks or vulnerabilities occur, the attack details must be administered and accessible to the cloud administrators. Now if we address the file storage. So companies are adopting cloud technology to transfer their complete or partial data from on-premises storage to cloud storage. Files or objects can be a primary source of getting damaged if any malicious file gets uploaded. Scanning should be performed daily of any size because it saves to minimize the risk of third-party users accessing and executing a malicious file. And then lastly, conformity and governance. So in today's world, there are data privacy regulations and the industries have to follow these standards strictly. So the main ones are GDPR, so General Data Protection Regulation, PCI DSS, so Payment Card Industry Data Security Standard, and HIPAA, Health Insurance Portability and Accountability Act. So when we're talking about cloud security, the important aspects to address as well as, things like General Data Protection Regulation governs where organizations can store data, how we can transfer data between locations and countries, where those users can have access. So we need to make sure we are aware of these regulations and the requirements to comply with them. So that's part of security as well. So we'll go deeper in the future series in each of the regulations and what we need to consider for them. But that's it for the security concepts in cloud computing. Now I just wanted to showcase a little example. So we talked about what is cloud, we talked about deployment models, we talked about shared responsibility. So this is what you presented in the graphic user interface as you connect to the cloud console. So as you can see, on the left we have AWS, and on the right we have Microsoft Azure. So normally they're very similar looking graphic user interfaces, but as you can see on the right picture in Azure, you have resources classes on the left, and then on the right you obviously have, if you click on, for example, as it says, number one, you click on virtual machines, and then you have in the main picture displayed a list of your virtual machines. And then on the left we have Amazon Web Services graphical interface. It's similar graphical interface as well. As you can see, number 4, it has a search bar. You have all of your resources in number 3. You have settings in number 5, and then you have obviously number 1 is your user, and then number 2 is your console and notifications as well. So this is a sort of graphical interface, but we will, as we go further into the series, I just wanted to showcase this graphical user interface, but as we will go into further into the series and discuss the enterprise security management, we'll discuss various ways how we can manage resources outside of the graphical user interface, and we'll discuss how engineers in an enterprise type of cloud deployments, how do they deploy cloud infrastructure, how do they manage them. We'll discuss potential problems that we run into, and how we can manage the cloud, and we go further into the series. Now, the next slide I wanted to address was the important part of cloud security is the cloud attack surface. So as we can see, normally we are faced with two main threats: external threats and internal threats. So as you can see, the external threats could be something like malware, zero-day threats, account takeovers, and new gen attacks. Internal threats, and one of the main common internal threats where we discussed just previous videos, is misconfigurations, insider threats, as well as compliance and regulations. And then you have your surface of attack. So you have networks, identity, and then control plane. And then through these three surfaces, then people can get access to your assets as well as servers and services. So the important way how we can manage the attack surface is get a complete picture of your attack surface. So discovery of all of the potential vulnerable assets is not what it used to be in the old days. Of the firewalled on-premise servers and encrypted remote access. Today, your attack surface is much more dynamic, with entry points that appear and disappear with a single line of code in some obscure policy as a code pipeline. So to get a complete view of your attack surface, you must monitor data at rest, in transit, runtime, and especially regarding cloud-based resources and applications. The second way how we can help ourselves is to automate asset and vulnerability discovery. So manual asset discovery in a dynamic environment is impossible. As you know, as we discussed, we can provision resources in cloud with a click of a button. So manual asset discovery will not help us, because sometimes, especially nowadays, resources can be provisioned and deprovisioned within click of a button, within specific schedules. So to effectively map and manage your attack surface, you must arm yourself with advanced tools that can discover and map out potential internal and external entry points on the attack surface in near real time. It's important to remember that these tools can help you tremendously, but obviously we need to make sure, I always tell people, processes, people first, technology last. So we need to make sure we have processes in place, we have the right people in place, and then we have technology that will help us solve these problems. The next important point is to reduce false positives. So the impact of alert fatigue on effectiveness and burnout of your information security teams is immeasurable. So false positives aren't the only relevant notifications that alert you of vulnerabilities that don't exist in your systems. False positives also mean unactionable alarms that fail to provide the context necessary to take preventative or remediation measures. We also have to ensure risk-based prioritization. So risk-based prioritization gives your teams a coherent sense of order and direction for tasks and assignments while first addressing the most critical vulnerabilities. The alert fatigue mentioned above is another reason to ensure all vulnerabilities are analyzed, contextualized, and given a specific risk score. You also have to make sure you build security awareness. So, as we know, and I kind of alluded to, human error is the leading cause of cybersecurity breaches. No tool or framework can bulletproof your systems against human error. So we need to make sure we create a practical framework to reduce human error and manage your attack surfaces with proper protocols, policies, processes, and awareness training. That's very important. Also, make sure you consolidate your alerts. It can be nearly impossible to make sense of it all between false positives, dozens of various monitoring and reporting tools, and automatic notifications to Slack channels and email messages, plus attacks don't tend to produce one or more alerts when they take place. Normally, they generate many warnings over time, just long enough for us to miss the connection between them. So you need to make sure you use advanced root cause analysis and mitigation tactics at the right time to get to the bottom of each alert. You also have to measure the value. KPIs and goals for your attack surface management strategy is essential. Now, how do we discover those weaknesses in our clouds? So we have to leverage vulnerability scanning tools. And vulnerability scanning tools are normally breaking down into a couple of tools. So we have vulnerability scanning tools that address infrastructure. So things like virtual machines and scanning them for their vulnerabilities. And also we have to scan our code bases, container images, software libraries that you use. We have to scan everything as often as possible to make sure we detect potential vulnerabilities before they are deployed into production. You have to make sure that you scan all of the assets. So as I said, servers, application, code bases, services, as well as the configuration. Another important point is part of the vulnerability scanning tool as well. When we move into enterprise cloud security, most of the cloud security is deployed for infrastructure as a code. So we can also scan our infrastructure as code files and discover potential weaknesses and misconfigurations in our cloud deployment tools. We also need to make sure we have asset discovery tools, shadow IT, or IT essentially assets that have not been discovered or you are not aware that they exist in your enterprise can be a potential great risk to your organization. So asset discovery tools are very important. Also, configure tools to achieve the best results. So, as I mentioned before, processes, people, and then the tools. You can have the best tools in the industry, but if they're misconfigured, if you don't have processes or correct people to manage those tools, you will not achieve security or maturity, and you potentially put yourself in danger. Because don't forget, sometimes people forget that adding specific extra security tools increases risk too, because these tools can bring access to specific resources. Misconfigured tools can also be an entry point for threat actors. Also, weak IAM configurations, so identity access management configurations, are one of the biggest problems. Most of you probably guys are aware how many breaches happen due to AWS S3 buckets. So if we rewind a couple of years ago, when you deploy AWS S3 bucket, which is essentially a storage account where you can store your data, by default, every single AWS S3 bucket was deployed with a public access, so anyone can access the data in the AWS S3 bucket. And there was a number of breaches where the data has been stolen from organizations. And obviously AWS made changes to make sure that by default the deployment is secure, because obviously there were organizations or there were people who are not aware of that misconfiguration, of that default misconfiguration, or they were not aware of their shared responsibility model, and obviously a lot of breaches happen. So identity access and management, it becomes a very key part of your cloud deployment models, and making sure that only the right people have access to the right resources. And lastly, application layer attacks is another way where we can discover weaknesses in our enterprises. And then the last slide we're going to discover in this series is most common misconfigurations that are currently discovered in the cloud. So lack of encryption, which we discussed previously as well. So data in transit and at rest has always have to be encrypted. So there is a few ways that you can encrypt data in the cloud, such as you can use managed encryption, which keys are managed by your cloud service provider, or you can manage your own keys. You have key vaults in cloud service providers where you can manage your keys, you can rotate your keys, you can store the key securely for the encryption algorithms for your encryption. Missing access restrictions is another major misconfiguration, as I just mentioned, guys. So making sure that resources that are deployed, firstly, they're not publicly available if they don't need to be publicly available, and secondly, we have access restrictions, making sure that we restrict access when we don't need to make these resources publicly available. Next goes weak permissions. So as I mentioned, especially internally, as users either move departments or change roles, if you don't have proper processes in place how permissions are removed or added, the chances are that you're going to have a permission creep in your organization, and people will have too much permissions that they need for their daily tasks, and the chances are that the data can be exploited. Also, lack of compliance program. It's very important to maintain a compliance program within your organization and adhere to regulatory and compliance requirements in the cloud. Also, improper data handling and retention. One of the key points of compliance programs, as well as regulatory requirements, is data retention. Making sure that we gather data for only as long as the business needs that data. Once we no longer need that data, we need to safely dispose of that data, making sure that we have data handling processes in place, data classification, making sure that our most sensitive data has the highest level of protection. Also, the next point of misconfiguration is insecure policy settings. Again, one of the most common misconfigurations in the cloud. Provisioning policies that have settings which are insecure. So we need to make sure that we address things like, potentially we are deploying the Kubernetes services. We need to make sure that we have proper security policies in place, making sure that how we manage pod-to-pod communication. It's very important, making sure how we provision encryption, how we provision our firewalls for our cloud deployments. And lastly, poor IAM controls, identity access management controls, are very important. Making sure that we have either multi-factor authentication or two-factor authentication for our users, making sure we can leverage nowadays in the cloud things like conditional access policies, making sure that we only allow users to access our platform based on satisfied conditions, to making sure that based on risk we create conditions and how we allow our users to access our platform. So hope that's sort of the introduction into the cloud. We covered some of the main concepts, some of the introductory terms into cloud security. Hope you guys love this series. Please like and subscribe if you like the videos, and I will continue this series digging deeper into cloud security, and hopefully you guys will join along the journey.